Thanks everyone for coming. This is Josh Essex from Opower. He's going to be talking about a project that he and some others built called Doodle or Die. It's a Node.js project. And yeah, let him take it away.
Thanks, Max. Thanks, I'm Josh. I'm a software engineer at Opower, an energy efficiency startup based in Arlington with offices in San Francisco and London. Basically, we create technology and targeted communications that help people make informative decisions about their energy consumption. So that's all great and good, but I'm going to talk about something a bit more important in the environment today, and that's online. So to start, who is familiar with Doodle or Die? Raise your hand. Anyone? 3 or 4 people? Okay. Who's familiar with the game Telephone? Okay, so telephone's easy. You whisper something into someone's ear. They modify it a little bit, either subconsciously or consciously. They whisper into the next person's ear, and then at the end it's something completely different. Doodle or Die is essentially that, but with drawings. We'll get into a quick demo soon, but these are the people behind Doodle or Die. 3 guys who kicked it off at a node knockout competition about a year and a half ago. Dylan, Aaron, and Garrett. Asher is our CEO, and I wouldn't say this to his face, but he's probably the worst CEO I've ever worked with.
He looks a little young.
He's young, he doesn't have experience, he's unprofessional, he's late to everything. He's talking about Cheerios. Stupidest little kid. I hope Dylan doesn't see this video. There's also Win, who is, he joined on shortly after. He's doing our mobile development right now. And then me. I mostly just fuck up the database on prod and have to push restarts. I don't contribute much beyond that. So as I said, it's a game of Telephone with drawings. And of course I can describe it to you, but you know, it would be better to actually show you what Doodle or Die looks like. So here's the interface. It's pretty straightforward. This is someone's getting prompted to actually describe a doodle that someone's going to draw. We have a little film strip of all the chains of doodles that I've been involved with recently, and then here's a chain that's in progress right below that. Let's actually join a chain that's happening right now, and so you can get a feel for how it flows back and forth between description and doodle. So someone's described a reptar fell down because he wanted cheese, and apparently that's what that is. Quick question, who watched Rugrats as a kid? Okay. Rugrats was my favorite show. Did you recognize Reptar initially? Okay, sweet. So someone describes that drawing as a cute Godzilla craves for some cheddar cheese, and we see something with googly eyes, and it's thinking about a wedge of cheese. So that's great, we're going well, chain's progressing. Then this happens, cute Godzilla thinking about cheese, and so we have a chibi dinosaur thinking about Swiss cheese. Okay. The quality of the drawing decreased significantly between steps. Next, the cute dinosaur wants some classic cheese. I don't know how classic came into it. And also, apparently, dinosaurs are only cute if they have lipstick and rouge, which I think is sexist, personally, but that's whatever. Dinosaurs should be free to have whatever partners they want. So then we have I can't really explain anything on top of that. The next step, that one's really technically impressive, because we do not give them tools to be able to do this. He wants Gorgonzola. So the chain went upward in quality, but then of course, no. So it became a chameleon drooling Jesus fishes over a yellow black dot. So that's pretty much Doodle or Die. Things tend to derail pretty quickly, but it always ends up hilarious, I think. So today I'm going to talk to you about the tech stack that sits behind this. I'm not going to get too technically involved with everything. There's a lot of shit that I could talk about for hours and hours and hours. I'm pretty much going to go through 4 main things: Node.js, Express.js, MongoDB, And I'll briefly talk about S3, which is an Amazon Web Service. So let's start with Node. Who's heard of Node.js, first of all? Would anyone like to tell me and tell the rest of the group what Node actually is? I knew Max would want to.
So Node is a server-side environment where you can use JavaScript to create network applications. And rather than spinning off threads for each request that comes in, it does an asynchronous, it uses an evented model. So you have a single loop that runs, and every time it runs, it says, oh, is there any work to do? If not, it continues. If there is work, it does the work, and then goes to the next iteration.
You actually just killed me, because that's like the next 20 slides is what you just said. That's fine.
He talks fast. I didn't hear what he said.
I'll draw it out and throw in stuff that's actually very high noise, and it'll be okay. So Node, that's a really good description. It's kind of hard to describe, but essentially it's a platform, it's server-side JavaScript. You use it to build networking applications, web apps. It's event-driven, which we'll talk about more soon, and it's asynchronous. Those are the two big things about Node.js. So what do we mean when we say event-driven programming? Really, that's all we mean. It's actions and they're triggered by events. It's not completely procedural and imperative. There are event detectors that are listening for certain events, and you have event handlers that respond to events that are detected. If you've ever programmed a game, maybe you have an event that's user presses space button, and your event handler says on space button, shoot bullet. That's event-driven programming. So it's cause and effect, like I said. And callback functions. I'm not going to explain what those are yet, but I made it very colorful because I want you to think callback functions for the next few minutes, and I'll come back to it. Asynchronous, no blocking. An asynchronous web app is one that never blocks. Even your I/O operations, they're all happening asynchronously, independent of the main thread. So let's say you're trying to render a web page on the server side, and you have to make a call to the database. That's going to take a very long time. It's going to pull the database. You want to be able to render the other parts of the web page that don't depend on the database operation. So you can spin off that I/O operation somewhere else, maybe in another thread, maybe in an event, as you do in Node.js, and you can continue to operate inside the main thread. And again, callback functions. That's the common theme that's going to tie together everything that's about Node. So how does Node actually work? Well, all I/O is event-driven and asynchronous. And I/O is the important thing here because web applications are I/O intensive, they're not CPU intensive. Node.js is built for web apps. So everything's event-driven, everything's asynchronous. There's never any locks because Node.js is actually a single thread concurrency. So there's no deadlocking. There's no shared state of databases or of data between multiple threads, so you don't have to lock, you don't have to do mutexes, anything like that. The page never blocks because all operations are asynchronous. And as I said, it's all single process. And it acts on callbacks. So again, with the stupid color, which I'm regretting right now, what are callbacks? Essentially, they're just functions passed into other functions as parameters. So say we're writing JavaScript, and we're sitting here in an environment, and we call function A. We pass it a few parameters, and then the last parameter we pass it is another function. We call it function B. When function A finishes its operation with all these other parameters, it's going to call function B. That's all callback functions. And that's pretty much the model of event-driven programming in Node.js. The finishing of this function A is an event. Node detects that for us, and the callback that we give it is the event handler. Simple enough. And because it's called an indeterminable amount of time in the future, we don't know when function A is going to finish. We just know that at some point it will be done, we'll call function B, and our event will fire off. That's why it's asynchronous. That's what we mean when we say that Node.js is asynchronous. So let's actually go to a very quick example here. All right, so this is a little bit of Node.js code. Is this legible to everyone, by the way? All right, so who can take a look at this for a second and tell me what they think is going to happen if I run this? Anybody at all?
It's going to print Daft Punk is playing at my house, and then every second it's going to print around the world. But
Why is it going to print Daft Punk is played at my house first?
because this is Node.js, and it happens in the last order you would expect.
That's right.
So it's to answer your question, it's asynchronous. So
Yeah.
the first thing it's going to do is that call, and then it's going to wait for you to pull it.
Exactly. So set interval is an asynchronous call because all calls that are built into the node core are asynchronous by default. There are certain blocking calls you can make as an alternative, but it tries to steer you away from that. This function that we define and pass in a set interval, that is a callback. So we have 1,000. And what's your name, sir?
Auto.
As Otto, you said?
Otto.
As Otto correctly guessed, 1,000 is the amount of milliseconds. And so what's happening is when you start up a node application, it falls into the event loop immediately. There's never any blocking. It's immediately in the event loop. It's going to idle for 1,000 milliseconds. It's not a busy loop. It's idling for 1,000 seconds, so your CPU can go off and do whatever the hell it wants. And then after 1,000 milliseconds have passed, events detected that it's done idling, and it fires off the callback that we gave it, which is to log around the world. Because it's asynchronous, it's going to call set interval. That's going to idle for its 1,000 milliseconds, and we're immediately going to go to console.log, which is Daft Punk is playing in my house. So let's actually test and make sure that that's what happens. There you go. So it's going to do that forever. Forever. And if you've ever heard Around the World by Daft Punk, that's exactly what happens. It's an amazing song, mind you, but it's super repetitive, which is great, whatever. So that's easy, pretty trivial. Let's actually go into something based on a web app. So here's another example where we set up a little node server. This require statement is node specific. It's not core to JavaScript. We're importing HTTP, which is essentially the node core. We're creating a server with that, and again, we're passing in a callback, which has two parameters, request and response. We're writing the content header to the response with an HTTP status of 200 OK, saying the content type is text plain, and then responding with hello world in any of the response. Create server happens. We tell it to listen to port 8080, and that is what starts the server and falls into the event loop. So once we tell it to listen on port 8080, the server's running, it's in idle, and it should progress to the next call, which is just a little log statement that tells us the server's running. So let's make sure that's what happens. So it logged, and if we go over to Chrome, load it up, there we go. So that is a very basic server in Node.js. Pretty simple, pretty trivial. Let's look here. That's not interesting. I could walk you through the entire Doodle or Die code base right now, but to prove to you that every Node app is not just one hello world file, this is what Node code might look like if you're not very good, which we are not. So again, that's just being stupid. So back. Hopefully you were impressed because that was my second thing I was trying to do. So to make sure we have it, Node.js is pretty much callbacks all the way down. It's extremely heavy callback chaining. That's its entire model. That's what single thread event-driven concurrency is. The node server, to create it, that's an asynchronous call. We pass it a callback that responds every time there's a request in the server. We're defining how to respond to every request. And request handling will probably trigger IO operations, which themselves are asynchronous, and are going to spawn more callbacks. There we go. So as I said, callbacks all the way down. Yes?
So the command to create the server is asynchronous?
The command to the http.create server, that's synchronous. Okay, server.listen is asynchronous.
Okay.
Yeah. Obviously, or it would be fun. Before we continue, any other questions about this? I went through it very fast, and there's a pretty steep learning curve for event-driven asynchronicity. That's weird. All right, I'm glad there's no questions. I've pretty much scraped the barrel about what I know. This is all pretty new to me, too. So let's talk pros and cons of Node.js. Super concurrent. because it's all a single thread, we don't have the standard one thread per request model, which is very difficult to scale. There's consistency, right? Because as Max mentioned, Node.js, you implemented JavaScript. And hopefully we all know the de facto client-side language in web development is also JavaScript. So that makes things easier to debug, easier to maintain. You don't have to have your team know multiple languages to work with a code base. Everyone can just be a JavaScript developer. And also you can share code, because say you want to do form validation on both the client side and the server side, which you want to do, you can just share that validation code across both sides. It encourages proper error handling. The reason for that is that almost every single node callback returns an error object as a parameter. So when you define your callbacks in Node, you have to have error handling. You can let that parameter go unchecked, but it's going to nag the developer. So every callback, it has an error right there in your face, and it's pretty much handled. So hopefully you do. Also, something that I won't go into a lot of detail, but if you've ever worked with Ruby, there are Ruby gems. If you've worked with Python, there are Python packages. You can just do pip install. Node has the Node package manager. And really, that's probably the biggest reason Node is as popular as it is already, is because of the Node modules. There's an extremely active community, constantly turning out new things. You can't build a Node app that's anywhere close to production ready without using NPM. But there are some cons too. As I mentioned, there's a very steep learning curve. A lot of people come from an imperative or an object-oriented background. Going into web development with the client side itself is difficult enough, but on top of it, the event-driven concurrent model is it's a little bit tricky. We've all had troubles with it. It can be potentially fragile. What I mean by this is that, as I mentioned before, when you launch a Node application, you fall immediately into the event loop. Unlike, say, using the event library in Rails, there's no blocking code that calls this event loop, which is siloed off. The event loop is the core language construct in a Node.js app. So if you have any unhandled exceptions anywhere in your code base that get fired off and they go uncaught, they go all the way up to the event loop, and your server dies. The web app is dead. So you have to be extremely, extremely careful about your error handling when you're doing a Node app, which is probably why all the callbacks have error objects in them. And the single-threaded event-driven model, it's great for I/O-intensive applications, obviously, because I/O is the big bottleneck in web apps. We're constantly writing to and from the database. This lets us do it in an asynchronous way and continue to respond to requests. But it's not great for a CPU-intensive application. You wouldn't do data analytics in just straight-up Node.js. That's how it is. So that's all I've got out of Node. But I have a quick interlude before we go into the next part. I think that the hallmark of any user content-based website is when memes show up and just spread like wildfire. And especially when people start to backlash against those memes. So the first meme in Doodle or Die was shark tits. What happened was we built this in a few days, and to get people excited about it, we went to the one place we should never have gone, which was 4chan. And 4chan shows up, and immediately they derail every chain with either shark tits as a description or doodling shark tits. That's not actually my interlude, because I want to be able to come back to the University of Michigan. So there's another meme called Homestuck, which I know I'm being taped right now, so I don't want to slander it. So I won't say anything more about Homestuck. Just know that it's a webcomic, and some of us are not fond of it. But that became very popular shortly after Shark Tits. Shark Tits just wore down. It doesn't have like comedic staying power, I guess. So people started breaking chains that gave them prompts to draw Homestuck stuff. And there's one doodler who I'm very fond of. His handle on Doodle or Die is Underwear Hero. And every time he got a Homestuck description, he drew something very particular. Every time he got a Homestuck description, it was Kermit saying that he's Batman in increasingly hilarious ways. He did this so many times, and I wanted to include every single one of them. but actually, this one's actually my favorite. It's so subtle. So that's mine. I just wanted to show Kermit. I want you to think of the super low "I'm Batman," and then think of how Kermit the Frog would say that. Right now, think about that for a few seconds. All right, we vocalized it. We can move on. So that's Node.js in a nutshell. So Express.js. So has anyone heard of Express.js? Who can tell me what it is? Not Max.
It's a web framework for Node.js that kind of makes Node suitable for like native web apps.
Thank you. And it's a Node module. You import it through NPM, and it's essentially a web framework that sits on top of Node. Makes things a lot more easier for you. It's asynchronous by design because it's a very thin wrapper around Node. So all of its calls are essentially just not literally piping, but metaphorically piping into Node and saying, do this for me, and do it asynchronously. Even though it's super lightweight and super flexible and thin, there's a very robust feature set. So we get a lot of things from Express. Route handling. For one, Node.js doesn't have automated route handling. You have to roll that yourself. And as an app grows, that does not scale. So Express.js takes care of that for you. Also gives you environment-specific configuration. If you've ever worked on a large production app, you know that there's half a dozen tiers. There's production, there's QA or test, there's development, there's the local machine-specific tier, and you'll have various different things. Your database may be different across all those tiers. Your app may have different behavior through all those tiers. If you work with clients and your app is multi-tenant, which means there's a different instance of the app for your different clients, they may have different configuration across those tiers as well. Again, that's not something that you get out of the box with Node.js. That's something that Express gives to you. Middleware, which I'll hold off on describing, but it's awesome. Middleware is pretty much the big reason, aside from routing, in my opinion, to use Express. And very easy templating, which we'll also go into. Very flexible templating as well. So routing. Who knows what I mean when I say routing in a web context? A few people. Okay, so you go to your favorite website, github.com, and you go to the home page, and it ends in /. That's a route. You go to your own specific profile. For me, it's JSX. You go to /JSX. That's a route. You go to the GitHub about page, github.com/about. That's a route. A route is just a relative path on the extension of the absolute URL. So in Express.js, we define these routes by the relative path in the verb. I guess I should explain that as well. And there are pretty much 5 canonical HTTP verbs. There's get, which is just get something from the server, give it back to me. Post, I want to create something on the server. Put, I want to edit something that's already on the server. Patch, which is kind of new and it's non-standard. It's essentially put, but there's very slight differentiation. And delete, I want to delete something that's on your server. There's a standard about how applications should handle requests of the different verbs and how they should respond to them. And if you have a web app that adheres to those standards, that's what it means when you hear someone say it's RESTful. So in Express.js, you define routes by the relative path of the verb, and you pass a callback into the function to define the response. So what does that actually look like? It looks like this. So in this example, app is our actual Express server. And you'll see we have .get, .post, .put, .delete. Those are Express core functions that define, given the first parameter, which is the path, or the route. This is the route that I'm trying to define. I want to respond to a GET request to /about with the logic that's defined by this callback function. I want to respond to a put request to this edit route with this callback function. You'll see this funky syntax in here. This is essentially :something is a path parameter. So that user ID in the put request or in the delete request could be anything. It could be 1, 2, 3, 4, 5. It could be Josh Essex if it's my profile on some website. It could be whatever. So that's what Express gives you. You just define all of these routes, unordered, it doesn't matter, they don't collide. And you define via callbacks how you want to respond. And so what happens is when you make a request to the server, it basically fires off, hey, I got a request. The node server continues to idle, and off somewhere else, we have a response defined by the callback that we gave it with the request and response parameters. That's it. Very easy. So let's have another example here. That's not where I want to go. All right, so let's modify this on the fly to use Express instead of just core node. So we will comment out this stuff that we don't need. All right, so again, first we want to import Express into our Node app. So we'll require statement. We'll define a server. Oops. And that's all we have to do. So that's our server this time. And now we want to define one route. So we'll say the base route. We'll pass in a callback function like so. And we will say respond with hello world. We'll tell it to listen, just like we did in Node on port 8080, and continue to log. Make sure that I did not fuck up. I'm still running here. There we go. If we go over to Chrome, just very, oops. Pull it up again, and there we go. So again, another trivial example. The code doesn't look that different. It doesn't look like it bought you much. So I'll actually show you some Doodle or die code to show where routing is actually, very useful, because this really doesn't convey it very well. So we go over to the Doodle or die code base. My resolution is completely fucked. All right, so this is a routes.js file. You see we're importing a ton of different node modules here and some custom code, obviously. We have this function routes, and you see server.post, server.get, server.all. All of these routes are defined here, all in one big file, and there's tons of them. These are all the API routes. We can also pull up, oops. It's not working for me. Oh well. So these are all the routes. And if we go over to our core app file right here, we have this init app function. And we'll just keep going, scroll down. Sorry. All right. So we have this routes API here, which we imported at the top of the file. We go up to it, we see it's just require controller API routes, which is that routes.js file I just provided to you. If we go into that file, we'll see at the bottom, there's module.export equals routes. This is a node standard. You say module.exports, and you come back with the functions that you can actually get out of this module. It's essentially kind of similar to defining an interface in, say, Java, for instance, or having a header file in C or C++. You're just saying, these are the functions that are available. This is my public API that you can work with. So we said that this, when you import the function, or when you import this file, it is the routes function. So when we say routes API equals require this file, we're saying routes API equals that routes function. And so when we used it at the bottom here, we passed in the server, and it immediately added all of those different requests to it. We passed our server object into the routes function, it defined all the routes, and we're done. Trying to do something like that in just bare bones raw node without actual route handling given to you would be absolutely disastrous. I'm not sure if that really gets across how important route handling is, but I see a few nods, so I'll just chalk it up to a win. We'll go back now. Okay, so I hope I did better this time. So middleware, this is what actually excites me. At its core, middleware is just a bit of code that extends functionality. It's basically glue for a software app. In Express, we express middleware as callbacks, and they're defined in order and applied to every request that comes into the server sequentially. So we have a bunch of middleware that we defined. You get a request into the server, it applies every piece of middleware to that request, and and then the request continues on unabated. So what does that look like? Something like this. Again, app is our server. .use is the express function for this is a piece of middleware to use. And then you pass in other functions. You pass in your middleware's callbacks. So express.logger is a function that sets up log handling for the request. Express.static is a function that says, hey, /public is where all of my static assets are. Know that for this request. We have a custom error handler here that says, on the response, turn caching off. And then we have an error handling request here with a slightly different arity. You see the one above it takes in a request and a response parameter. Error handling in Express takes in an error object as well. And if you remember back to what I mentioned about the one con of Node was fragility, that an uncaught exception could take down the whole web app, this completely blanks that out. Now this basically becomes the catch-all for the event loop. If there's an uncaught exception that bubbles its way all the way up to where it would crash the event loop in a raw Node app, this catches it and responds with oops. So Express just completely eliminated pretty much the main deficiency of Node.js. So all these are defined in order. So this is completely illegible. There's a lot of code, and it's all middleware. So take my word for it that there's a lot of cool stuff happening here. We're handling bad URLs and responding with custom 404s. We're doing authentication. We're doing a little bit of light error handling. So every time you make a request to do or die, all of this middleware is applied. And this is only about a third of the middleware that we actually apply to every request. But I was trying to succeed and make it readable, and I still failed. So I apologize. But every time you make a request, this happens so that this can happen. And this can happen, and this can happen. So that's all middleware. I mean, it's not all middleware, but middleware makes this possible. And that's why I like middleware so much, because I get to see SpongeBob and Oprah. So that's terrific. Templates. Now we delve into the client side just a little bit. Basically, a template is HTML with minimal logic. Ideally none, but web development has been a very long and fruitless journey into logicless templates that has never really succeeded. So as little logic as possible, mainly variables and conditions. So with conditions, you can do things like, if this variable is this value, then put the div here. If it's not, then don't display the div at all. That's all a template is. And you can use it to dynamically render a web page, just as I mentioned. You can insert variables into what would otherwise be completely static. Partials are basically parts of a page. So say, in the case of do or die, we have the little canvas that shows the actual Doodle step with, you know, the T-Rex or the little chibi T-Rex or the drooling chameleon with the Jesus fish. We want to display that many times on a web page, and we want to display it on many different web pages. So that Doodle itself could be a partial. And we can just put that in other templates wherever we want. Templates are composed of many different partials, which are other templates, which can be in turn composed of many other templates. We call that partial because it's part of the page. The two benefits of that are, one, that it encourages code reuse. You don't want to have to define the same divs and spans and everything all over the place. It also encourages UI consistency. Self-evident, I think. And they can be rendered on either server or client, which is primarily how a Node app works. Is it renders a very bare bones partial on the server, it passes it back to you, and then you do some client-side stuff and get more partials back to actually assemble your page in an asynchronous, non-blocking style. So how do we do it? We use EJS. That is one of many, many, many different template engines. Express can support theoretically any template engine which adheres to its signature. We use EJS, which stands for Embedded JavaScript. Any templating engine, in my opinion, is as good as the next. If you asked Garrett, who does all of our client-side stuff, he would slash my throat for saying that, but there's no difference between any of them. Client-side JavaScript is pretty much how everyone builds the client side of their app. Do or Die is extremely client-heavy, and you'll notice that I'm talking entirely about the server because that's what I actually know. I don't do client-side stuff for the most part. I try to stay away from it because I'm terrible. So jQuery, which is pretty much the standard JavaScript library for doing anything on the client side, So how we actually build things is we make asynchronous calls to our API. Our external API that people can build off of and our internal API are one and the same. So we make calls from the client side back to the server through the API, and we get that data back as JSON. Sometimes it's data about a player, it can be data about a chain. Either way, we get that data back, and we inject it into the partial, and then we render it on the page. So that's how we can asynchronously and quickly put together a page with dynamic content from all sorts of different sources. So again, it's not legible at all, which is upsetting. So a template like this is how you get something like this. That's how you get a badger with a monocle and a mustache stealing chicken from KFC. You'll notice that that's, again, Underwear Hero. He's probably my favorite doodler. He's really good at drawing badgers. So that's pretty much all I have on Express, some pros and cons. It takes away a lot of development. As I mentioned, route handling is the big one. Handling routes in Node.js without Express or some other framework like it would be an absolute nightmare. So don't do it if you can avoid it. And going back to the point about the error handling in Express being able, through middleware, to take away, crashing your entire app. Express in that way and a handful of other ways covers a lot of node deficiencies which do exist. It's lightweight, it's flexible, it's very thin despite its robust feature set. It doesn't get in the way. It's pretty much just a layer of syntactic sugar on top of Node that does a bunch of shit for you. It's awesome. The one con I can think of is that it's almost too configurable. Everything in Express can be configured in a fucking Cambrian explosion. Did I get that right? Combinatorial explosion of configurable things you can do with Express across every tier, across clients, across browsers, and it can be really challenging, especially if, like me, you were completely new to Express and you had no idea what you were doing. It's tough. So I have another interlude. That's all I have on Express. Really quick, any questions about Express.js? Great. So I need a volunteer for this interlude. No, not Max. I need one volunteer to just come up here and do something for me. It's going to be so easy. No one wants to volunteer. Adam, thank you. Give him a hand. Thank you. So you are going to live doodle for the entire room.
I'm a really good artist, so it'll be good.
Let's go over here. Pull up Doodle or Die. The resolution's sucky. I hope we can get through. Let's play. So you have to doodle. Does anyone know Gallows Singing with Saria? Who's Gallows Singing? I know Saria, but I don't know Gallows Singing.
No, I don't know Gallows Singing.
No? This isn't good, is it?
No, the next one.
Let's skip that. That shit. You can describe this. Doodle that.
I can do that. All right. Cool.
I spend a lot of time at work on our intranet actually doodling, and occasionally you get something like that, like an ejaculating ghost, and you just have to hope that nobody's watching you. I haven't gotten too many HR complaints yet, so it should probably be okay. So this was Pink-Headed Ninja kicks 2 pink stars?
Pink-Headed Ninja is about to kick 2 pink stars. All right.
Why don't you walk us through?
All right, so I'm going to make,
As an artist,
I'm really good at this. We're going to make a body. And we should probably make stars too, because just so we know where the legs are going to go. So we got a star, and we're going to make this challenging for the ninja. So we're going to put the other star over here, and then I really need this trackpad someplace. I'd never be able to do this in my lifetime.
What's really nice is using like a walk pad or a What is the second bend?
This is his knee. His knee is right here, and this is his foot. So he's got like a really short. He was in an accident. Come on.
It's foreshortening, master of perspective.
Wow. And then let's see here. He's not a ninja yet, so we gotta put one of these on. And we'll, like tie this off up here. And then there's some eyes. Yeah.
He's a blue-eyed ninja.
Fuck yeah. Oh, wait a minute. Yeah, it's we'll make him, well, we'll make him green. How about that? Just because you made fun of his eye color. He needs two directions. properly get his kick both stars at the same time. And he's a little frustrated, so we're gonna put we're gonna make him. He's like, well, there we go.
What is that expression?
Confusion. He's trying. He doesn't know whether he should smile or not smile. So.
All right.
Yeah.
Is that all you got?
Yeah, well, now you got me all thinking about this knee down here. So I think it works. All right, so now I'm good with this.
Yeah.
Doodle.
There you go. You can keep going.
I'm gonna
I
do,
just realized what that was.
Yeah. We need a new drawing. Draw anything I want. Oh.
I don't want you to hog all the fun. Does anyone want to draw?
Yeah, who wants to draw? Who's an actual artist?
Ian, get up here. Perfect.
We need a new drawing.
Round of applause for Ian and for Adam.
Totally volunteered for that, I guess.
Yeah, you did. Anything you want at all.
Well, how about some inspiration, guys? Any ideas?
Well, he's an artist, so yeah, we should crowdsource what he should draw, right?
Yeah,
All right.
I'm doing this for hire here.
So do we want an animal or do we want a landscape?
We're Bob Ross in this, man.
All right. We're going to try to draw a landscape.
Build some quick mountains. Let's see.
I'm very glad this is all happening on my Doodle or Die account.
You really need a good artist, didn't you? So I'm glad I could help. This one might actually look okay.
If I start taking too long, we need to move on with the presentation.
No, I do not care at all.
You draw the mountains.
Yeah, can I log in next?
So that's a sky ostensibly,
Yeah, we're gonna have
but
to.
it overlaps the mountains.
We're gonna have to redraw the mountains, I think. You know, it's all signature Bob Ross though to kind of just throw it on and.
Oh, can we just draw Bob Ross?
I'm gonna put him in the foreground, I think.
Bob Ross in his own picture.
Bob Ross in an easel at the easel on the shore of a lake.
Can you draw Bob Ross doodling this doodle?
Oh wait, this looks really. We put this slightly bolder line.
You can
on
undo
one side.
Okay.
I noticed there's no like dry palette knife setting.
Is it a Klondike bar?
In there, build some happy little clouds.
Even if you're thinking to yourself right now, this is terrible, this is still better than any doodle I've ever made. I like how this hush has been falling down. It's working.
putting layers on it? Why didn't anyone tell me to put layers on the Ninja?
That was self-evident. Is there a time limit on this, by the way? Like, should we be ending at any particular time?
So,
We can just go. Okay.
What? Carl, do you know how long we have the room for?
Till 8.
Okay.
So another hour?
Yeah. We're fine. Doodle for the next half hour. Come on.
this is a good time to get some more pizza if anyone else is hungry.
Thank you.
Everybody gets up.
You're putting a lot of effort. For your accounts.
That is indeed a horse thing.
Let's see. Get this 7. Just gonna put a little lake in here.
That's good. Those are the doodles.
all the other pictures.
Is that a reflection? Yeah, of course.
Oh my god.
This is way too good.
I gotta build some happy little trees. Like that. I need like a darker shade of green.
We're actually in the middle of a redesign right now. That gives you a full color palette.
Nice.
And a continuous spectrum for radius. Whoa. Undo.
I suppose if we do something.
So how does it actually, how is the data saved on this?
That will be the very next part of the
Oh, okay.
presentation. And my favorite part, that's what I actually like. Not to say I don't like all the other stuff I spoke about, just not as much.
I think I'm reaching my capabilities here.
This is really good. I'm very glad for this.
And now,
Bob Ross.
yup. We really have a great skin tone.
No, we do not. That's been pointed out. There's actually a Doodle or Die Chrome extension that gives you whatever color you
That
want.
won't do it all. I think we might have to go just white. Yellow is like I was tempted to go with yellow just because Lego men, but then like just because my childhood was full of like yellow people doesn't mean it doesn't really look like skin, does it?
Not that shade. It's like, what is it, scurvy? Is that the one that,
Jaundice.
or is it's jaundice and liver failure? That's, yes.
I'm better at landscapes than people. Nah.
It's a very realistic smile. His eyes look completely soulless.
Add a quick twinkle in them. There we go.
That's even worse. Wait. It's like he's focusing on something. So he's confused.
He's looking fairly happy. Come on, give me a break here. This is what. That wasn't as successful as that. All right, last little detail here. Trademark.
Oh, it's the color palette there.
He just has big
On his
hands.
head. Paint time.
Whoops. Selected it. It's not select everything.
Click off canvas.
Flame? Yeah, something like that. And then real quick.
I love how his perspective is. He's like, he's inviting.
He always said that. He was like, if it's your first time joining us, I want to personally welcome you to the show. Drag out your oil paints and paint with us. Thanks again for allowing me back into your home.
You watched a lot of Bob Ross.
It's like PBS puts it all on YouTube. Let's see.
There was another show I saw as a kid growing up that was kind of like Bob Ross, but it was this old hermit that lived in the mountains of West Virginia. He called himself Pappy. And you would actually jump into the painting like Blue's Clues style every episode. Did anyone? No one else saw
I
this?
think I know what you're
I
talking
think I know what you're talking
Maybe.
about. Yeah.
All right, I think I'm done.
Hey, look, it's
That's
an animal
great.
with a landscape.
That is absurdly good. All right.
Hey, it's a fox in the grapes.
We'll leave that for now. So thank you very much for that. That was awesome.
Did you ever change it updated?
Oh, that's awesome. Let's see if Adam's chain got an update. Yes. How is it?
Rome.
So it started as a Roman soldier, and it was this. So that got described as ninja cheerleaders will kill your So I think we can see where this is going. There, no. Ninjas fighting off two pink fuzzies. Wow, that's oddly similar to Okay.
See, I'm really good at this.
No one has liked it so far.
Oh, come on.
Someone will like it, I promise. I like it, but I can't vote on my own account. That was described as and that's where we're at. I think it's really fascinating from like a linguistics, like sort of cognitive perspective to see what chains the same themes persist really long. Like in that dinosaur chain, we saw a dinosaur and a block of cheese every step. But other things get broken really fast. I just think it's fascinating to think about. That's not why we're here. So let's talk MongoDB. It's a NoSQL data store. And when people say NoSQL, they typically mean it is not relational. It's really an overloaded term at this point. But MongoDB is neither SQL and it's not a relational schema. In fact, it's almost structureless. The very minimal structure that's provided is that everything is saved as essentially JSON. It's actually BSON, which stands for binary JSON. But for all intents and purposes, you can just imagine that you're saving live JSON into a data store. So for those of us who are familiar with SQL, come from a relational background, these are pretty much the analogous terms. You have a database in both. You have a table that's filled with many rows that have predefined columns. In Mongo, you have a collection of documents with undefined fields. And the undefined part is the important part that we'll get into. Also, how you put together really complex queries in SQL is typically through joins, left, right, inner. There's no joining in Mongo for reasons that we'll get into, but there is embedding and linking. So first, what is a collection? Really, it's just a group of documents completely without constraint. You basically think of it conceptually. You could have, in Doodle or Die, we have a collection of players. We have a collection of chains. We have a collection of groups. But you don't actually instantiate these the way you would an SQL table, where you say create table, table name, here are the columns. Just the first time you insert something into a collection with such a name, the collection comes into existence with that document. You don't declare any fields, how you declare columns. So there's absolutely no constraint on what can be inserted into a collection. If you were really bad, you could just define one collection and insert all of your data into it. That would serve no purpose, but you could do it. You can't do that in SQL. But it does tend toward homogeneity. Programmatically, your reads and your writes to and from the database tend to specify the same fields. And so over time, your data will become consistent, it will become homogeneous. You'll have documents and collections that tend to have the same fields by and large. So what is a document? Really, it's just a JSON object or an array thereof. Everyone, I hope, has seen JSON. We'll see some in a second. And documents contain fields. That's pretty much all they are. A document is a JSON object with some fields, and it can have sub-documents, which are just other bits of JSON embedded inside of it. Sub-documents can contain further sub-documents. It can nest further. So embedding. Embedding is when you actually nest a sub-document inside of a document. It's very useful on the server side because you can retrieve a sub-document like any field. So let's say at Doodle or Die, we have a player collection. So every document in the player collection can have a sub-document that we call game, which is just a representation of their current game state. Are they going to doodle next? Are they going to describe next? What chain might they be working on, etc. So you can specify a sub-document and pull that back out of your query like any other field on a document. And it's very easily handled by the server because Mongo can see inside of documents all the way down the tree. So it can see every sub-document all the way down. Very easy to handle. The alternative to embedding when you want to link different collections of data in Mongo is linking. It's essentially referencing one document from another. So say we have a player. He has a sub-document that we call chain history. And in each chain history object, we have basically a representation of all the chains he's ever worked on. And inside of that, there's a chain ID. That's essentially linking from player.chainHistory to chain. But unlike SQL, it's not a foreign key type dependency where that data is rigorously defined. And if you try to insert a linking ID that's not defined, it will break. You can insert anything into any field in Mongo. That's the big takeaway. So if you have what you consider to be a linking field in your mind and it points to something that doesn't exist, then that's a problem. You have to enforce that on the client side because Mongo doesn't handle that for you. So typically the way you do linking is follow-up queries. You'll retrieve a bunch of players, and then if you want to get every chain that a player's been in, you do a follow-up query to get all the chains that were pointed to from inside of the player document that you got back. So here's an example Mongo save query. We're saving a comment into the comments collection. DB is our database, comments is our collection, we're saving. And this JSON object that we're passing in is essentially the document, right? This is the actual comment document. We're specifying a field, or an ID field, a chain ID field, that's linking. A player ID, that's also linking, but again, those things might not actually exist. We just hope that they do, and if we're doing things correct on our side, that they should. And the text of the comment, this chain is swagtastic. Another example, so now we're looking at the players collection, and we want to get back just one result. That first object is specifying the fields that we actually want to pull back. So we want to pull back one thing from the players database, one document that has an ID field with that value. That second parameter is specifying what we actually want to pull back. So we're saying, I want the chain history subdocument on this player document. So it comes back with the ID, and sure enough, the chain history document, which in turn embeds actual chain history objects, which in turn have fields, date played, date viewed, none likes, etc. So it's JSON, as I promised. Another example. This time we're doing some very heavy embedding. So again, we're querying on the players collection, but we're saying I want a document from the players collection whose game subdocument has an active state field equal to phrase. And what I want back is the login subdocument's password subdocument's UID field. So that's essentially a query that says, find a player, give me his user ID, any player who is currently at the phrase stage of the game. His next step is going to be to type a description. And that's what it comes back with. The login object embeds the password object, embeds the UID field with the value of josh.essex. That's it. So how does Do or Die actually use it to actually save these doodles? That's where it gets interesting. We call our model of saving data question-oriented. What we mean is that inside of the application, we want to be able to answer questions. When someone logs in, the question is, who has these authentication credentials? When we're displaying the actual chain of doodles, we have a lot of questions we want to ask. We ask for every doodle, how many people have liked it? For every doodle, what's the actual content? What are the brush strokes on the canvas? So our entire structure is geared toward being able, with one query, to answer some question. Or one subquery, yeah. And to do that, we have to use heavy embedding. Because as I mentioned with linking, there's no foreign key dependency where you can say, I want to join these two tables and bring me back this sort of amalgamation of data. You'd have to do follow-up queries. Our model is one query per question, so we have heavy embedding of subdocuments. It's very good on the server, we think. Pretty efficient. It's not good in all cases, but in our case, it's great. So an example question we might want to ask, what is this player working on right now? Easy. Find the player with this ID, give me his game state subdocument. I can work with that. How active is this player? Again, here's his ID, give me his game stats subdocument. I can work with that too. Something a bit more complex. What recently modified chains need a new doodle right now? So what chains that have been worked on recently are in need of a new doodler? They're not assigned to somebody. Like that. Ensure index is, actually I should ask, who's familiar with the concept of an index in a database? Okay, so I want to ask someone to explain. I'm sure you're all tired. I'll say it myself. An index is essentially a data structure in a database that specifies that some column or some field, in the case of MongoDB, is going to be searched rapidly. So every database system will implement indices differently, but the takeaway is that essentially an index is sort of like this magical thing that's applied that says your reads will be faster, but your writes will be a little bit slower. That's the takeaway from an index. So we're saying use the index defined by these three fields. It's not in use. Its active state is that it needs a new doodle and it was modified recently. That's essentially what that means, although in a somewhat obtuse manner. But the point is, we ask questions from the app. We code them as queries, we get back data, and it's very easy to translate that into something that we can work with from the development perspective. We know what question we're answering, so this is how we respond to it. So how do we actually save the doodles? Well, we have a collection of chains. I keep using the term chain. It seems basic to me, but some of you might have been wondering what a chain is this entire time. A chain is just a series of Doodle steps. Description, Doodle, description, Doodle, description, Doodle. That's one chain. So we have a collection of chains. A chain embeds, not links, embeds many different step objects. And a step can be a description or a Doodle. That step, in turn, embeds its own content. Now, in the case of a description step, that's just embedding the text of the description. It's a field inside of the step. Inside of the content subdocument, inside of the step document. But, and I promised S3, that's not where our Doodles go. MongoDB is terrific at horizontal scaling, but it starts to break down at extreme data loads. Our Doodles take up a lot of space, so we put them on S3. So the actual metadata for a Doodle step, how many times has it been liked, who doodled it, when did they doodle it, when was it last viewed by another player, that's inside of our content step in MongoDB. But a Doodle is a series of brushstroke objects. There's a color, there's a radius for the brushstroke size, and there's the path that the brushstroke followed along the canvas. That is stored in S3. This is what a Doodle looks like representationally. We have a color, we have a size, and we have the path that it followed, which, if that's not obvious to anyone, which I'm sure it's not, it's just a series of XY coordinates. So 307.66, 308.66, 308.68, 308.69, that's the path that the brushstroke followed along the canvas. You might be asking, why do we save a Doodle as a series of brushstrokes? Why don't we render it as an SVG image and just pop that as a blob into the database, which we could do. The reason is that we want to be able to replay Doodles back. We want people to be able to see how a Doodle evolved over time. So if we just took the canvas Doodle, turned it into an image, put it in the database, all we'd be able to say after the fact is, here's the Doodle, this is how it turned out, this is the conclusion. We wouldn't be able to follow how the Doodle changed over time. By encoding each individual brushstroke object, we can play it back. So you have a bunch of these, and the result is this. But unfortunately, that's for the lovely legal department at McDonald's. That's not your mascot. So it's this, but it's also this. This is actually, I don't have a Facebook account, so the other doodlers who have a Facebook account tell me that this is the most popular doodle of all time by Facebook likes. There's also a Doodle or Die subreddit, and this is the favorite one on Reddit. If you're curious, and I don't know why you would be, the description that led to this was Pop-Tart Pokemon. And they look like bullet holes, but they're actually the little indentations on the actual Pop-Tart.
Strawberry filling.
Right. You'll see he's bleeding strawberry filling from his mouth. His eyes are cracked because he's very dry because he just came out of the toaster and he needs lotion. And he's got, no, that's 5 toes, that's right. It looks like he has 6 toes on the back foot though, which leads to the question, like, how did evolution create something this grotesque? How is this adapted to survive in any environment?
So the toes is what
That's what does it. It's not the structure, it's the toe count on the back foot. So this equals this. That's the main takeaway from this presentation. That equivalency. So some other tips related to Mongo. Store everything. We have a big web app. You'll have all sorts of metrics, especially for something that's user-generated and people are interacting and they're engaging. You may not think that you need certain metrics, but later on down the line, especially if you're trying to incorporate your startup, you'll want those metrics on hand. Always specify fields in Mongo. As I mentioned, there is no declaration of fields on the actual server side, so the client is in charge of specifying that on reads and on writes. On reads, you always want to specify fields because if you don't, as it's going through and pulling back everything out of a collection, every time it encounters a new field on a document, it's essentially going to think to myself, okay, I should try to get that off of the next document. So as it's going through the table, it's pulling back the superset of fields that exist on every document. For a collection that's not very homogeneous, maybe something that's new, this gets very bad performance very quickly. It's also just good programmatic practice to specify the fields that you get back so you know exactly what data you're interacting with at the service layer. use indices. I mentioned them briefly, but it's very, especially for us with our question-oriented data architecture, there are certain fields that we're querying all the time, so we put indices on those fields to make sure that the reads on that are very fast. There's a little bit of a hit on the write performance, but we read 1,000,000 times more than we write, so we accept it. So some pros and cons of Mongo. Pro is that it's optimized for the most common use case. In web development, that's a lot of reads and some writes. It's optimized for that. And it's very good at that use case. Other ones, not so good, but a standard web app Mongo makes a lot of sense. Also because essentially Mongo commands are JavaScript. The Mongo shell is JavaScript, the Mongo syntax is JavaScript-like, and you're dealing with JSON as your actual data, which obviously is easily parsed into JavaScript because it is JavaScript. So it goes great with web development, especially in our case where we have JavaScript on the server and client side, because now we're using one language from data all the way to client. It's great for rapid prototyping. The story of Doodle or Die is that it was built in 48 hours during a hackathon. I know you guys have a hackathon tomorrow, so disrupt Doodle or Die. So it's great at building out something very fast where you don't know what your data schema is going to look like in the future, because you don't have to specify a schema up front. You don't have to worry about what fields are going to be there. You can just start adding documents to your collections and they'll be there for you. It's horizontally scalable. And what I mean by that is Mongo is very good at sharding across a distributed data store. So you can have a lot of different servers and Mongo will shard very cleanly by just how it was designed. Cons of Mongo. The data structure is obviously not obvious at all. In SQL, you can do describe table, you can do show create table, because the table was instantiated with certain columns. That doesn't exist in Mongo. So to know what the actual data structure is, you have to pull back data and look at it yourself. The client has to maintain data integrity for the same reason that I just mentioned. So if you start inserting data from form input, for instance, and you're not actually validating what you're inserting, your data can end up in a terrible state. So you have to be very, very stringent about what you're accepting and what you're persisting. It's non-atomic for multiple collections. I could speak on this for a while because it's a deep topic. Data systems have this measure of compliance that's called ACID. It stands for atomic, consistent, isolated, and durable. Atomic means that a series of related queries will be all or nothing. So if you are doing an insert across many tables that you join together, and it turns out to be 3 or 4 queries, and any SQL distribution, because it's ACID compliant, if there's like a power failure and your server goes down and it's executed 2 of those 4 queries, the 2 that were executed will not actually be persisted. It's all or nothing. It's atomic. Mongo is not atomic. So say you have a web app which is an online store. Someone puts an item in their shopping cart. It's a 2-step process. We take it out of the inventory, we put it into their shopping cart. If there's a power failure after we've taken out the inventory, but before we put it in the shopping cart, it's too bad. That first query was already persisted, it's in memory, it's going to end up on disk the next time we swap. But that second thing, actually putting it in the shopping cart, what's really important here, will not be saved. So now the inventory is in a state that's not technically correct. Our data is partial, and things are very bad. There are ways you can get around that. You can do atomic queries on single collection queries, and you can actually sort of parallelize things, and you can invent data structures over top of your database to create the semblance of atomicity, but it's messy and it's wonky. So it's a definite con. Also, there's reduced query flexibility. If you're doing, like at Opower, we do a lot of data analytics, and so we frequently have to do ad hoc queries on the fly. Our analysts are constantly looking at the database. The main way that you assemble an ad hoc query of sufficient complexity in SQL is through joins. Those don't exist in Mongo, so you're at an extreme disadvantage if you have to do things on the fly. So that's all I have on Mongo. Are there any questions? Any Mongo-related questions? Yeah.
I'm Mongo related. Do you know what the distribution is of brushstrokes? Are there a bunch of doodles with like very few brushstrokes and a bunch with a lot?
Yes, I do know that. It's actually a normal bell curve. And the bell is at about 95. Somewhere around 100 brushstrokes is where most people top out. But there's actually, if I think I have this correct. There's actually a small bump. There's a lot of or a lot of doodles that are like 10 to 20 brush strokes, and that's it. And then it just smooths the rest of the way. Yeah, and there's something related to that I'll get back to at the very end. So some other things that are just interesting: Doodle is hosted on Joint, which is very good. Source code's hosted on Git, and putting those two together, we can actually deploy our code just by doing a simple Git push. So every time we merge a feature branch and we want to push something out live, we can just do a Git push. And there's a hook on Joint, which will actually run all of our unit tests. If the unit tests pass, then it pushes that code and does a hot deploy, and all of a sudden the website's been updated seamlessly. If the unit tests fail, then it emails us and says, shit's broken, I'm not deploying. And the code continues to live as it was in its previous state. Yeah?
What do you use to unit test?
I probably should have talked testing framework. Mocha. Remember Mocha, look it up when you get home. Mocha is pretty good. There's also another one called Testacular, which we've dabbled with. Not to be confused for a word that sounds similar. I'm not implying that it was named intentionally for that reason, but it was named intentionally for that reason. So Mocha is what we use. Testacular is also pretty good. There's 100 different test frameworks to play with. Other things. So I have a few node modules here that we use that I'm very fond of. Async does a lot of asynchronous control flows for us. So you can do parallel, you can do serial, you can do waterfall, you can define very complex things like these three processes can happen independently of each other, but this one depends on these two, and this one depends on this one. Async lets you do that in a way that's readable, manageable, and succinct. NodeMon is essentially a wraparound node. So instead of doing, earlier we did node helloworld.js to launch our server. You can do NodeMon helloworld.js, and what that does is hot restarts. So when you're doing local development, you're changing all these files, you want to be able to see what your changes actually do to your web app without having to restart the server. NodeMon does very quick restarts, so we use it. Passport is very easy authentication. At present, you can authenticate to Doodle or Dive through Facebook credentials, Twitter credentials, or standard username password, and we have some other credentials that we're working on down the line. Passport handles all of that for you. It takes all of the authentication work, for the most part, out of your hands, and you just have to make sure that Passport's looking at the right session data on your end. Pretty easy. One other thing is log everything. This isn't readable again, but this is the output of me tailing our production logs. So we get a Doodle approximately every second, 24 hours a day, and a description every second, 24 hours a day. So we're constantly like just watching them come in. We have a hook where any Doodle that's over 150 brushstrokes, we turn it into a block image like this and put it right in the logs, so that if there's a particularly interesting drawing, we can see it show up in the logs right in the flat. So this is Vegeta crushing his power scanner. And this looks like it says 9,000, I'm not sure, but I'm almost positive because there's no other thing it could possibly say. So log everything, store everything, log everything. If you learn nothing else when you're developing a web app, those are the two things to remember. So that's actually all I have. Any questions at all? Or would you like to throw pizza at me? I don't know. I've done a terrible job. Yeah.
When you store all these drawings and brushstrokes, how big is the average?
The average brushstroke is really small in the order
No,
of
I mean, but like when you store these files, like that's a lot of storage, right?
It's a lot. Actually, the reason it goes on S3 and not Mongo is largely cost effectiveness. We write doodles pretty much once, and then we just read them a lot of times, right? The doodles don't get modified after they've been saved. It turns out just by the cost modeling that S3 and AWS in general gives you, if you're doing a lot of reads, but not a lot of writing in the other way, it's pretty cheap. So we have a couple hundred gigabytes of doodles in the 1-year history of Doodle or Die. So a couple hundred gigabytes is what we have total. We have, I think, something on the order of a few 100,000 doodles. So do the math in your head and you see what a doodle looks like. But we write the doodle, and S3 essentially just becomes a flat storage. Here's all the doodles. also all of our static content and our daily database backups. But S3 is really good at just being a dumb data store that you need to read, but don't write to all the time. Obviously, we write to it every second, but that's really not a lot in the grand scheme of things. Anything else?
Thanks, Josh.
And that's it. Thank you.